Hello, this is Mr. Jackson. Today I want to go through solving some basic force problems. Before I start, I want to make sure I let you know on a piece of vocabulary that shows up in positive physics. A lot of the questions ask you to solve for the magnitude of some forces or the magnitude of acceleration. And the word magnitude just simply means, really simply, just means the size of something. It's a numerical answer. So if I ask you for these two forces that are acting on each other, I ask you what's the size or the magnitude of the net force. So you look at these two forces and you have 50 this to the right and 20 to the left, then you cancel them, and so you end up with a net force of 30. 30 is the magnitude. It's still just a net force. It just means magnitude means what's the size of your answer. If I had two forces that were 140 in the opposite direction, then my magnitude would be 60. So the word magnitude just simply means size of your answer. So don't let that confuse you, okay? But I want to give you a set of steps to solving these problems, okay? So let's look at the formulas that we have gathered so far in this unit. We have gathered basically two major formulas. F equals ma, but I've been writing it as F net, so that you remember that's always got to analyze the forces that are going on. And do they add or do they subtract? And of course, if they were going in the same direction, so if we had two forces and we had two people pushing on a box, one pushed from behind and one pushing the other direction, okay, and one was pushing with 20 and the other was pushing with 30, then we would have a net force of 50. So F net equals 50 newtons because they're both in the same direction. They don't have to be on the same side of the box. Forces that work in the same direction add, forces that are in opposite directions subtract, okay? So that was F net, okay, is equal to mass times acceleration, which we know is meter per second squared. But remember, it's not always gravity, so I want to be careful there. That may not be 9.8. But how we also may need to also find the force of weight, and the force of weight comes from this equation. Weight, which is a force, is equal to mass times gravity. So gravity is what creates weight of an object. And if you go to a different planet, your weight would change because you'd have different gravity. Okay? Force has newtons for units, and so we look for numbers with newtons. We know they go in a force point and the force part of the problem. If it has masses, it goes in the kilograms, and if it has meter per second squared, they would go into the acceleration part of the equation. Okay, so these are our two major equations. Okay, and so we want to make sure you remember that, and then we want to also talk about the steps that I'm going to be following. So I always give you a procedure on how I approach problems. So here are the 4 steps that I go through. Number 1, I draw the problem, and I decide, is that problem horizontal, vertical, and what is mentioned should I neglect? That means I'm not going to draw those certain forces. Okay? Then, after I draw them, I begin to write down all the givens and then decide if it's going to be horizontal, then I know the force of weight equals a force normal. I also can find weight with mass times gravity. So I start to fill in forces, even if they're not mentioned. There are ones that we must realize that are always present. Like force of weight is always present unless you're in space. Okay? So any problem where you show you a car or a box being pushed across the floor, we must use weight. And we will always use 9.81 for Earth-type problems. Okay? Then I solve for these 4 major ideas: F net, M, A, and W, force of weight. And if they're given to me, I put them in my given list. But these are the ones I need to help me solve for any unknowns they may ask me. Then I go on and I begin to solve after that for all the rest of the unknowns they may be asking me for, and then I fill them into the answers. So let's go through these 4 steps with a couple problems, okay? So here, I'm going to do 2 problems. I'm going to do a horizontal problem and a vertical problem. So here we go. Here's a very typical problem in positive physics. A car with a mass of 10 kilograms experiences a drag of 60 newtons and a friction of 20 newtons on the road. The engine is pushing with a 120 newtons. And the questions they'll ask in positive physics, well, how many forces are acting in this situation? What's the normal force? What's the net force? What's the acceleration? And is the speed increasing, decreasing, or remaining constant? And it's really simple to do. All you need to do is begin to draw your forces. We know, number one, on any level situation, force of weight always acts downward. Okay? And in a horizontal problem, force normal always pushes up from any surface it sits on. And these two forces are always equal because there's no movement in this vertical plane. It is always horizontal with bikes and cars and that kind of stuff. Now I need to add in other information that's been presented. It says there's a drag. A drag is always opposite the motion. This car is moving that way, so my force of drag must be this way. So force of drag, and it's going to be 60 newtons. Okay? It mentions also friction. Friction is also an opposing force. It acts opposite of motion. So it also would act backwards from the road where it interacts right here. Okay? And so that force of friction is 20 newtons. Okay? So I've identified those, and it says the engine is pushing, so we have what we can call as force of thrust or force applied, whatever you want to call it, it's fine, of 120 newtons. Okay? So I've identified, I can't think of any other forces that are in here, nothing else has been mentioned, and so if I go around my circle, force of weight is there, so we have 1, 2, 3, 4, 5. Okay, and these must exist, so I have 5 forces that are present in my problem. Okay, now I told you earlier we want to then start figuring out, because we have force weight and force normal, and force weight is mass times gravity. Can I figure out those numbers and start filling in this list? So I want to find F net, M, A, and FW, because if there's something over here that's not part of this list, these primary things will help me solve for things over here. So force net, since it's horizontal, I look at these two forces and I got to add and subtract. I have 120 this way, okay, and then I have 60 and 80. These add together because they're in the same direction. So we have 80 newtons of resistant forces. So to find F net, all I need to do is go 120 minus 80, and I find 40 newtons. Okay? And then I want to find the mass, because that could help me find weight and that kind of stuff. They mentioned mass right here. That is 10 kilograms. Okay? And I don't have enough information yet for acceleration, or I could, because F net equals ma. But force of weight, here they ask for force normal. I know these two things are always equal in every horizontal case. So if I could find the weight, I actually find the normal force. Well, weight is simply mass times gravity. So I'm just going to take 10 times 9.81. So 10 times 9.81, and that gives me 98.1, and that's a Newton number because it's force. Okay, and so I can actually add, so if this is 98.1 and there's no motion in this direction, then this must be 98.1 newtons. So this is 98.1 newtons. Okay, and then it says what is net force? Well, I found it because I analyzed both the horizontal situations. We have 40 newtons left over. Now if I want to find acceleration, all I really need to do is take my first equation and solve it for A. So I'm going to divide the M away. So A is F net divided by mass. So all I have to do is take the net force, which is 40, and I divide it by the mass, which is 10. Okay? And so that answer is going to be 40 divided by 10 is 4. And the units are meters per second squared. So 4 meters per second squared. And I could put 4.0 or 4, but that's probably because it's worked out just fine. Now, since the applied force is greater than the resistance forces, that means this one wins. So the energy of the engine is beating the resistance. So it will be speeding up. So I would say my speed is increasing. Okay? So that's how I would fill in that list right there. So I'm focusing on these ideas and using these steps to help solve these unknowns. So I'm going to look for these right off the bat, and that'll help me fill in the list. And I keep some of these ideas consistent, that I know horizontal problems are unique from vertical problems. Okay? So that's how I would solve a problem like that and fill in my list. Okay, let's go on to a vertical problem. Here we have a 60 kilogram rocket experiencing air resistance of 120 newtons while firing its rockets to produce a thrust of 600 newtons as it lands. Okay, so the first thing we want to do, our step number 1, is draw our plan. Draw all the stuff. Is it horizontal? Is it vertical? Did it mention neglect anything in here? It didn't, so I'm going to go on. I know I have a force of weight that always acts down. That is always there. It didn't say it was in space, and it didn't say to neglect it, so I'm going to do that. I'm going to assume it's in the atmosphere. It says there's air resistance, so that's a drag of 120 newtons. Well, if a rocket is firing upward, drag is always downward. So force of drag, and that is equal to 120 newtons. Okay, and then it says it produces a thrust. Its rockets produce a thrust of 600 newtons. So if the rockets are pushing down, the thrust pushes it up. So we have force of thrust of 600 newtons. Okay, and there is no horizontal information in a vertical problem, so I don't need to draw it. Okay, so I can figure out this force of weight. I told you earlier, it is mass times gravity. So all I got to do is take the mass, and I go through here, and it does now has a 60 kilogram mass. So I'm going to go F net, M, A, and FW, because these things help me fill in this list. And if you don't want to write this out because it's right here, that's fine as well. I forgot to write down it gave me 60 kilograms in my given list. Okay, and so if I want to find out how many forces, here I've analyzed it. I got 1, 2, 3 forces. And then I want to find the weight. I told you earlier, it's always good to find the weight right off the bat. So force of weight is mass times gravity. So I'm just going to simply go clear, and 60 times 9.81, okay, is 588.6. So 588.6. 588.6, and this is a Newton number, okay? And if you want to get, you just call it 589, because that's 3 significant figures. That would be acceptable. I'm pretty sure in positive physics was all he'd want to see. Okay, so I'm just carrying one extra one for this moment. And then it says, what is the net force? Well, if I'm positive I've got everything identified, I've only got 3 forces, then I begin to look at opposite forces. I've got up minus down. So that means this is going up and these are going down, but these are both down, so these have to be added. Okay, so 588 plus 120. And that gives me 708.6. So let's just call it 709 newtons. Okay? But that's how much is acting downward. And I have 600 up, so this one's going to win. And F net, force net, is pretty much always absolute value. So I'm going to make it just a positive number, okay? So we're going to go 708, which is down, 709, minus 600. So 709 minus 600. And I'm going to write it down as 108.6, or 109 newtons is what I have left over, okay? So that's my net force. And then if I want to find acceleration, I go up to my formulas. F net equals ma. There's acceleration right there. I just need to know the mass and the force net. I just found the force net and I have the mass. So to do that problem, it's real simple. All I got to do is A is F net divided by mass, which is going to be 109 divided by 60. Okay, so 109 divided by 60. equals, and I got 1.81 or 1.82 meters per second squared. So my acceleration would be 1.82 meters per second squared. That would be my acceleration. Okay, and then the question then says, is my speed increasing, decreasing? Now there's a couple clues. Number one, it says it's landing, so I don't want it to be going up still. I'm trying to land, and so this rocket is setting down, so we're trying to come down and land on something. And so this number is bigger, so it's pulling it downward, but it's still, so this is going towards the Earth and setting down. So it's probably slowing down, so it probably was moving up at one time. So I'm going to say it is decreasing. And so whenever the vertical one and the bottom force is greater, it's decreasing. If you're doing a horizontal problem and the negative drags are bigger than the applied, then the speed would be decreasing. Or if there's only drag and friction and there's no force to the front, but it was moving, then again it would be decreasing. So I just want you to think about that. Okay? So that's how I would start all these problems. Simply draw the problem, analyze the forces. Remember, vertical don't have horizontal forces. Ones that are sitting on a plane, and there are horizontal and vertical forces. The two vertical are always equal. And then you want to do that. If you draw it, you want to try finding your basic ideas of F net, M, and A, and force of weight, because that pretty much occurs in every problem. And then solve for the rest of your unknowns using your little list of information. And then you can fill in your answers on positive physics. So there you go. Give that a shot and attempt those problems on your own. Very good. Thank you for listening in. This is Mr. Jackson.